Okay, so today let's talk about buying resistors for your projects. So here's what I need to do is that you see I have these coupling caps here which are from the space splitter, and they go to the input of the output tubes, and one of them has failed, so it had to be replaced. If you want to see how that looks like, you see that whitish thing close to the center pin. So this used to be the lead wire like that, but I just clipped it off on both ends. And as you can see, that's the mark, that whitish mark there, that internally there was a short. So this thing just shorted out and burned out. And after I fixed it, changed it, it wasn't enough to fix the amplifier. The sound was still quite distorted. And the problem was that when you have such an event that a coupling cap fails, often the capacitor, which is your load on the vacuum tube, that also suffers. And here the problem was that the resistor, which is like here, this guy, that's one of the loads, and here that's the other one. So that's the resistor that failed. But these are in pairs. So this resistor has to be the exact same value as that resistor to split the phase evenly for both tubes. So because this is how it is, so let's just draw the schematics a little bit. Just this part, the phase splitter. So these are those resistors that you see there. There's the gradient of the tube, plate, cathode, and here these are those coupling capacitors which drive your output tubes. And this is where the signal comes from the driver tube. And here this capacitor has failed. So there was a short between the two plates. And because of that short, this resistor also suffered. So it changed value. So it was supposed to be 23.7K, and it drifted to something about 28K or so. And this means that the amp still functions. However, because of the imbalance, because we have here 23.7K and 28K, the difference is big enough to create distorted sound. So that's why we need to change those resistors there. So that resistor and that resistor underneath the other tube. So actually I have two units, 1 and 2, and I checked all of these resistor values, and none of them are close to the original. They are at least 5% off from each other. So now let's see that if we want to change it, how do we go about changing these resistors? Because the original, it says 23.7K, and if you are looking for a resistor, you have to get something that is of equal wattage as the previous one. So because if you get smaller wattage, then you are stressing out the resistor more, and that's a cause for failure. And when you think about failure, it's not just imminent failure, so you turn your amp off and it blows, but as you use the amp for years and decades, if the resistor is stressed out too much, which means it's running too hot, its value is going to drift. And that's the thing with these phase splitters. So when we have this phase splitter configuration, that we are splitting the phase with a single vacuum tube, and we are using one output from the plate and the other from the cathode, because they are in opposite phase. So it means that if the signal here increases, the signal here decreases. And that's why you have to keep these values the same, because then the amount of increase is the same as the amount of the decrease. and vice versa. So here we go, that if we keep the resistors the same, it doesn't really matter whether it's like 33.7 or 23, I can't even talk, I'm sorry. Or is it like 24K or 23.5K? It doesn't matter as long as you keep both of them together. If you are doing any tube rolling, your tube rolling is going to have a bigger impact on the sound than whether it's 23.xk or whatever. So you don't have to, it's not the end of the world if you are looking for resistors and you don't find exactly 23.7K resistors. What I'm doing is I'm using 24.0K resistors, and they will be just fine. You just have to know that if you go significantly lower, like you go 22K or maybe 20K, then you are going to let more current through the vacuum tube and you are making the tube run hotter, and you don't really want to do that. Or maybe you want, you will change the operating point of the tube so it will sound in a different way, but it also means that you are going to shorten the tube life. You can go the other way around. You can increase the resistor value maybe to 30K, and then it will draw significantly less current. It means it will live significantly longer. But now, because it is of a higher value, lower current running, it means that the RP, so the plate impedance of the tube, will go much higher, and it won't be able to drive the output tube at low frequencies as well as it does now. So what are we doing? So I'm using 24K resistors, but these buggers, they didn't have it at my store where I got it from at 1% tolerance. They only had 5% tolerance resistors. So what's the deal here? Because what you want here is to have the resistors, like the plate resistor and cathode resistor, as close in value to each other, and the closer the better. And when you order resistors, when they said it's 5% tolerance, it means that whatever batch you are getting will be within 5% of the value. So if it's like 24K, it means that it can be anything 5% less than that or 5% more than that. However, due to the manufacturing process, when you have resistors that were manufactured, that were rolled off from the manufacturing plant at the same time, they will have pretty close values together. And what you need to do is just, instead of ordering 4 resistors, because I am changing these pairs on both of the amps, I ordered 5 resistors, so 1 extra. And let's see that when we measure it, what are the values we are getting. So I measured it with my meter. I'm not showing that process because I don't have 3 hands, so I cannot hold the camera. But the thing was that these 2 resistors on the top, they were exactly 24.03 ohms. So it's not just 1% tolerance, but even tighter tolerances than 1%. And it says 5% tolerance on the order sheet. This guy here was 23.88K, so that was like pretty off from those two. But these two fellows down here, they were 24.23 and 20.4.22K. So these were also like 0.1% tolerance within each other. And what can I do this way? So I use the top pair for one of the units, and then I have a pair of resistors which is better than 0.1% matched to each other, and I use these lower 2 pairs for the second unit, which is about 0.0, what is that? Yeah, 0.01% tolerance. So if you want like really close tolerances like that, you can get it from resistors which are advertised as a 5% tolerance, and you can get two pairs which are pretty close to each other. Sometimes you get so lucky as I did now that it's within 0.01% tolerance, but usually you can get 0.1% tolerance, like this is a 0.1% tolerance per pair if you order 5 resistors. So there's just a way of how to plan for your project, how to plan for when you need to order resistors. So thank you for tuning in. Bye bye.